Hi, class. Today we're going to talk about what a rational number is. But before we do that, we have to understand number sets. So numbers are grouped into certain sets. So, for example, a natural number, these are numbers you kind of learn in elementary school. It's basically skip counting by ones. So numbers such as 1, 2, 3, 4, 5, these are all natural numbers. Now, whole numbers pretty much are the same as natural numbers. It includes natural numbers, but it has one extra addition. We now add the zero. So now we start the skip counting from zero instead of starting it from one. So it's simply just 0, 1, 2, 3, 4, 5, and it continues on. Integers now include the negatives. So we start from zero, we can go up by one towards the right hand side, and we can also go backwards by one towards the left hand side. So then instead of going 0, 1, 2, 3, 4, 5, we can also go 0, -1, -2, -3, -4, -5. Now, rational numbers include all integers, whole numbers, and natural numbers. Rational numbers are, so basically, if you're an integer, a whole number, or a natural number, you are also a rational number. Rational numbers are defined by if it can be expressed as a fraction, it's considered to be a rational number. And irrational numbers are the opposite of rational numbers. Irrational numbers basically state that if you can't put it as a fraction, it's not a rational number. And common examples of irrational numbers are as a decimal form are decimals that don't terminate and they aren't repeating. So what that means is decimals that continue on forever, but they don't have a consistent pattern. And basically for rational numbers in decimal form, if the decimal stops or if the decimal continues on forever, but it has a repeating pattern, it's still considered to be a rational number. And then a real number, this just includes both rational and irrational numbers. So, for example, if we look at rational numbers here, it says 2 is a rational number. 2 is a rational number because you can express 2 as a fraction. If you recall, 2 over 1 is 2 divided by 1, but 2 divided by 1 is still 2. So, hence, this is a rational number because you can express 2 as 2 over 1. You can also express -4 as -4 over 1. That's a fraction. So, it's considered to be a rational number. And then 0.5 is simply just a half. That's expressed as a fraction. And then 1/3, which is 0.3 repeating, it's already expressed as a fraction. So we're going to say that's rational. So all of these numbers are rational because you can express them as a fraction. Now, if you look at the irrationals examples here, you have pi. Pi is 3.14159, and it keeps going on forever. But although it keeps going on forever, it doesn't have a repeating pattern. It simply just generates random numbers that keep going on forever. And because of that, we call that irrational. Now, root 2, anytime you take the square root of a perfect square, you basically get a nice number, right? But 2 is not a perfect square. So when you take the square root of 2, you basically get the number 1.41 ... The dot means it goes on forever, and it doesn't go on as a repeating pattern. So because of that, it's considered non-repeating and it's non-terminating because it goes on forever. So we're going to call that an irrational number. Now, if you look at this chart here, basically, just like what I said, natural numbers, whole numbers, and integers are all considered to be rational numbers. Irrational numbers are opposite from rational numbers, and then real numbers include both rational and irrational numbers. Now, in this case, the symbol R represents real numbers, the symbol Q represents rational numbers, and the symbol Q with a dash above it represents irrational numbers. And then I would represent integers, W represents whole numbers, and N represents natural numbers. Now, this is the important part, being able to identify what is rational or not. In this example, which of the following numbers are rational? Justify your answer. Now recall, as long as you can express it as a fraction or in decimal form as a terminating decimal or repeating decimal, it's considered to be a rational number. So in this case, -1/4, because it's already in a fraction form, I can say it's a rational number. Now the square root of 9, recall the square root of 9 is a perfect square because two numbers that multiply to get 9 is 3. So in this case, this would just be 3. But because 3 can be expressed as a fraction, I can say the square root of 9 is a rational number. -4 over -9, I can already say it's a rational number because it's in fraction form. But if I were to simplify it, two negatives divided together get a positive. So I simply get 4 over 9. That is a rational number. Now, the square root of 75, because 75 is not a rational number, if I compute this, I'm most likely going to get something such as 8.66 dot dot dot, meaning it goes on forever and it doesn't repeat. And because of that, I'm going to say this is not a rational number, because to be a rational number, I have to be able to express this as a fraction, but I can't express a decimal as a fraction if it doesn't terminate or if it doesn't have a repeating pattern. Pi we already talked about. It is essentially 3.14159 dot dot dot, meaning it goes on forever and doesn't have a repeating pattern. So it can't be expressed as a rational number. 0.25 can be expressed as a rational number because right now it's a decimal that already terminates, so you know it's rational. But as a fraction, it would be 1 over 4. Because you can express it as a fraction, that's a rational number. Now this decimal here looks like it goes on forever because of the 3 dots, and it looks like it doesn't have a repeating pattern. So this would be a irrational number. So hopefully that gives you an idea of what a rational number is and what a irrational number is.